So let me give you some idea about Docker before we go through the theory. Okay. So if you go to the olden days, and suppose I want to set up the project infrastructure. So what was the scenario that time? Suppose I want to form the team of two developers, two developers, two testers. Oh, sorry, one tester, and suppose one team lead, right? So, okay, hiring is okay, but again, in the back end, I have to allocate some machines to them, right? I have to create the servers as per my project requirement. So what was happening? I was raising the request for hardwares. Suppose I need a machine of 16 GB and 8 cores, okay, something like that. And I need, and suppose 1 TB of hard disk. And I need such kind of machines which are of 6 boxes or 6 servers. And again, I want them to have CentOS 7 installed on them. Okay. Or generally we go for Red Hat Enterprise Linux. And I don't know which version of the Linux is going on right now. I'll check it quickly. Just it is good to be on same line. RHEL 8 and 9 versions are going on. Okay, so suppose I want to have RHEL 8 version or even 7. So it is better to use little bit backward version or the version which is supported by the Linux or IBM in this case. So let's assume that 8 is supported. So something goes wrong, we can contact those people and we can fix. So again, these machines were purchased, everything will be installed. And again, suppose on these machines, I need MySQL. Okay, I need Oracle. I need Nginx. I need Mongo also. I need a web application, right? I need email server configuration. I need Java installed on those machines and so on and so forth. So out of this 6 servers, let's assume that one server will be my database server, another will be my web server, another 2 will be my development server, and so on and so forth, right? So again, let's assume that this is my development environment. So similarly, there will be pre-prod or UAT SIT environment. And again, there will be little bit more powerful boxes on the same line. So development environment is little bit lightweight, but when it comes to the non-prod environment, similar kind of server I need to go and set up. And then finally, there will be a production environment. So this is my non-prod environment. Let's assume that we have this 3 environment only. So this is development where development team will be doing development plus testing environment, I can say, means SIT testing. And suppose this is my UAT environment where before production, we are bringing some non-production data, which is similar to the production, and we are testing. And then finally, we will have more powerful hardwares and real-time setup where we need to take care of lots of things. Because something goes wrong in production, and even if you test anything in UAT, but we don't know how things will behave in the real time. That is our production environment. So that's where similar kind of boxes, similar kind of setup will be deployed, and that will be my production. Again, it was manual process. So you can imagine, so purchasing this box, again, that is costly affair, setting up them. So I need to contact to the network admin team, give them all the list of softwares, their versions, again, MySQL, which version I want to install, Oracle, Java, again, which version I want to install, Mongo, Nginx, and lots of things were there, and it was critical. Again, what operating system I want to use, and suppose I want to test it in multiple operating systems. So suppose I'm testing in Linux, REHL, but I want to test it in Ubuntu also. I want to test it on Windows servers also, and so on and so forth. So things become more and more complicated, right? With this physical setup where I need to to purchase those boxes and set up everything. So that was cumbersome activity, right? So that's where we got some revolutionary concept, and we got VM later on. Okay, so VM was one of the revolutionary concepts. So as part of the VM, what was the case? We have this hardware layer here. Then there was a virtualization layer. Okay, so this is my hardware. This is my virtualization layer. Okay, again, some software I'm deploying there. And then on top of that, I was able to create virtual instances, virtual machines on my box. Means assume that this is my machine, which is of this entire machine, which is of REHL, Red Hat RHEL 7. And I did virtualization on this. So on that single machine, suppose this is a CentOS machine, CentOS. This is Ubuntu. This is suppose Windows Server, and let's say this is RHEL, something like that. So single machine is used for creating different images. This is my virtual machine with certain operating system. So this is my VM1, this is my VM2, VM3, VM4, and this entire machine, which is of REHL, which is hosting all these virtual instances. So this is the VM. And now beauty is what? These are the powerful servers. Now suppose I want to do some work which requires CentOS and plus some additional softwares here, suppose. So suppose I need Oracle, web server, Nginx, or something like that. So I want to configure, suppose load balancer. Sorry. So what I was doing, some application. So these virtual machines were coming up with some pre-install applications also. Application means in this case, database server, web server, or any other utility which is required for, suppose I required Ubuntu with Python. So this Ubuntu is coming with those pre-installed softwares there, those virtual machines, right? And that way, now it's very simple, right? So suppose I want to provision 4 instances of REHL. So I'll create REHL 6, 7 instances and I'll install those respective softwares here. And that way my development environment at least ready, right? So very easy thing. Now I don't need to provision hardware, give that list. As a developer, I can decide what kind of softwares I want to have and what kind of images I want to have. I'll take up that and I'll install. But again, the problem is where when it comes to the VM virtual machines. So virtual machines were combination of operating system plus applications or plus install utilities, right? That was the case. And again, when we talk about performance and speed, so what was the case? So whenever we talk about performance means how efficiently we are using our hardwares, right? How efficiently those softwares are running on that hardware. So here there was one problem. And what was that problem? My operating system was consuming my resources. So when I say resources means it is all about hardware. So when I talk about hardware means we have a CPU, we have a memory, right? We have a hard disk, we have a network interface, network bandwidth, right? Network. Then burst traffic. Burst traffic means all these devices are connected with some cables, right? So there was problem. I mean, CentOS. So generally, if you go and see the servers are black and white, right? Why they are black and white? Because if you make them UI oriented, unnecessarily resources server resources will be consumed for that UI activity. So most of the server, they are command driven only, black and white screen. We have to run all the commands manually there because why? We want to keep the resources, mainly CPU, hard disk, bus traffic for managing the actual activity, means database server. It will be installed on non-UI kind of operating system. Why? Because actual hardwares will be used for that DB activity, DB server, connect, taking the requests, processing those requests, and those are more performant. Those kind of DBs environment, they are more performant. So that's where we use lightweight operating system as a server operating system, right? So that's where this problem was there with those VM. They were coming with their own pre-installed operating system version. Then again, there was another revolution. And what was that revolution? So again, we have this box, and this box can be of two type here right now. It can be your VM or it can be a bare metal. Bare metal means actual hardwares. VM means virtual machines. Whatever we saw here, these are VM. So this machine, this powerful machine can be a VM machine or bare metal machine. And again, this machine will come up with its own operating system, right? And it is coming with one additional virtualization layer, or they call it hypervisor, I think. Let me just check it out. Just checking the name. So not hypervisor exactly, but yeah. So what they did, they come up with some libraries here. Again, lightweight virtualization layer. And now what happened? We we got some images here on top of these libraries. These images. And now these images are without uh, actual operating system in them. Means what? Means I can select Ubuntu version, but that operating system is not there. It's a part of normal installation, right? I can install CentOS, but actual OS is not installed there. It is just library support of those operating system, and I have the actual application there. Means suppose Oracle server. So these were the lightweight images, and those were without the actual operating system, no OS. So these images, when we run, we call them container, and this is what containerization technology. Okay, so in VM, what we saw the operating system here, but as part of the Docker and those container image, so they come up with those tools and libraries here. Actually, it is here. It is here as part of the container. It is here, and here we have that virtualization layer, which is known as Docker here. So Docker technology will take care of spawning these images. This is what Docker, right? So rather than being actually instantiating that operating system, they come up with the tools and libraries, and then actual application means it could be database server, web server, and those being installed, and that way it was executing. So this is the revolution. And right now we use this container, which are very lightweight, and whatever we do in the container, those things are being used for the actual application execution, and the resources are efficiently used. They are more performant. So that is the advantage of container. So what we are going to see, so we are going to see Docker and its introduction. And today also we are going to install Docker on our remote box. So that's where in the message I told you, please configure your EC2 instance and connect to your EC2 instance. Then we are going to see the difference between what is container and what is Docker, right? How to run container. So we are going to run bunch of commands as far as containerization is concerned. And some life cycle things and images and port redirection if time permits. And going forward, we will create some Docker images also, our own custom images, and we will deploy them and we will release them also. And how and what we will see that. Okay. So what is container? I told you, right? So container is a standardized unit of software that packages up code. Code means your actual application. So in this case, suppose you want to install Oracle server. So it will have the Oracle server code. And in order to run the Oracle server, whatever dependencies are there, whatever supporting libraries and tools are there, so those will be installed. And apart from that, as part of the Oracle, suppose you want to install it on CentOS. So those supporting libraries and whatever configuration is required, so that will be there in the container. So that container will be of, so there are two things in that container in that case. So the first thing, so that container will be of, will be supporting the CentOS plus whatever basic operating system libraries are required, right? We saw ls command and all those things. So whatever basic support is required, that is there. And it has all the necessary things pre-installed as part of the Oracle server. So when I start that container, so there are two things here. Okay. So the first thing, we have a image. So whenever we install any operating system, so if you go, we have a CD, right? Using CD, we install that operating system and that get installed. Then later on, we got some virtual images, right? OVM files, open virtual machines, and those things came. So that was again set up. So we were installing that virtual machine set up on my local machine and using virtualization tools like Oracle Virtual Machine. We were running directly that operating system with that VM, right? So similarly, here we have a image, Docker image. This is my Docker image. And that Docker image is nothing but the software. And that Docker image has all these things there actually. Okay. So this is my software. Right now you can assume, suppose you want to run Oracle. So how do you run the Oracle? So in order to run the Oracle, you first install Oracle, right? And then you start the Oracle service and Oracle will start working. So similarly, this is the image. This is the software which has all necessary things as part of the CentOS plus its supporting libraries, and Oracle setup is there already pre-installed. But when I run it, when I run this image, when I create the instance of this image, right? So that Docker image become container. So we call it container. So container is what? Running instance. Running instance of Docker image. Right? And now in this image, we will have actual Oracle service running here. And I think Oracle port number is 14 something is there. Let me just check it out, Oracle port number very quickly. I don't want to give wrong information here. So port number, I want to see the Oracle port number. So they say 1521, right? So here we have a port number 1521, right? And now suppose you run some other container as well, and where you install client utility. Okay, Oracle client is installed there on the same machine. This for Oracle client container. Okay, again some Oracle client image is there. This is Oracle client image. So this is Oracle server image. Let's assume that Oracle server image, Oracle DB server image. And suppose there is another image, which is Oracle client image, Oracle client image. So again, whatever client utilities are there, those will be installed here, right? Oracle client utility. And when we spawn this image, it will create a running container, right? So from this image, we will be running a container. So right now, this is that container in this case. Okay, let's assume that. And we can run multiple container. Huh? So one image. So this is my first container from this image. So I can run another container also from same image. I can run third container also. And all these are Oracle clients here. Okay. All these are Oracle clients from this image. So they will have same thing. But again, on top of that, I can do some customization here also. It will have its own space, right? So in this way, all this client will be running, and these clients will be suppose in a position to fire some queries to this server. So select star from this database, create database, or any data analysis they want to do with this Oracle server. So they can fire those query from their terminal, right? SQL command line. And in this way, these were the images. This was the container. And from one image, I can even spawn another container here. Okay. And these are the clients. So in this way, we have an image, and running instance of that image is nothing but the container. Okay. So go back to the theory part again. So code, dependency, system tools, configuration, settings. It is a lightweight standalone. So container is what? This container is lightweight. And it's very lightweight instance. Standalone executable package that include everything needed to run the application. Or in other terms, containers are isolated execution environment available for Linux Windows based systems. So they are available for Linux and Windows distributions. Software runs consistently irrespective of underlying host OS. So underlying host OS. So right now in this case, we have a container of CentOS, but same Oracle server can be installed or created with the REHL Linux. It can be created with Ubuntu Xenial operating system. So that is possible. Okay. So in that point in time, I would have three different images. So I will have three different images of Oracle server. So Oracle 10, let's assume that. This is the first image where it comes with the bundle with CentOS plus Oracle 10. Then there is second image which comes with REHL, again specific version, Red Hat Enterprise Linux. So Red Hat 7, CentOS 7 plus Oracle 10. Oracle 10. Then we have another image, suppose it is with Ubuntu plus Oracle 10. So I just need to take that image, spawn that, and test the things associated with that. So these are again very standard software, Oracle. But suppose tomorrow you develop your own website and you want to test that website with IIS, Windows web server. You want to test it with Tomcat. You want to test with Nginx. So you can deploy those same website on this different web server, and you can check the nature, how it works in Tomcat, how it works in IIS and other web server, or in combination with other operating system. So that you can do using Docker, creating those Docker images and deploying your custom software into those images. Okay. So Docker is industry standard, lightweight, no OS. So even I say that is CentOS, but not actual instance of the OS is running there. So we have things like this. Infrastructure here means what? Your hardwares, and hardware in this case, infrastructure means what? It will include multiple machines and network also. In the backend, we have a network, right? All these machines are connected with various network topology, star topology or hierarchical topology and all those things. They will connected with routers and hubs. So that is what my infrastructure. Then one machine, it must be having its own operating system. And on top of this operating system, there will be the layer of Docker. So one Docker daemon service is running on this machine. So when I gave this example here, so when I say this Docker means one that Docker daemon service is running here, and that Docker service will take care of instantiating or orchestrating with all these instances by running some commands. So we are going to see all these commands. So whatever commands we run, that happens with this daemon service, Docker daemon service, right? And these are my Docker instances. So Docker provide application isolation. So one application is completely isolated from others. So this can be my database server, web application, email server, or so on and so forth, right? Something like that. Ease of management, scaling capability, right? So suppose I created this image with 2 GB of memory, but later on I felt this application required more memory at the runtime. So I can increase it to the 4 GB and that way I can run it. So I can scale the resources, scaling capability at the runtime, right? That's where we call EC2, Elastic Compute Cloud. Elastic means what? Runtime. If it require more hard disk, we can add it. Require more memory, we can add it. Require more CPU power, we can add it. So it's a elastic EC2. Docker is a platform and the tool for building, distributing, running Docker containers. So Docker is a platform on which we run all these Docker containers. Client daemon and Docker IO registry. We will see what is Docker IO registry. So we again, Docker is a client server architecture. Means whatever Docker daemon I told you, that is what our Docker server. So on the same machine right now, here we have a Docker server running and all necessary client utilities are also installed. And that's where we are able to run the Docker commands there. So this machine has Docker server as well as Docker client. Same thing happens with our Oracle. So generally when we install Oracle server, so along with Oracle server, we install Oracle client utilities also. And that's where from the same machine acts as a Oracle server as well as Oracle client. Same thing here, okay? Or we can, suppose we want to have some other machine here and which should act as a dedicated client, sorry. So what I'll do, I'll just install Oracle client utilities here. Oracle, no, not Oracle, Docker client utilities. Docker client utilities. And those Docker client utilities will communicate with this. There will be some configuration files. And within that configuration file, we will say that this client should communicate with this Docker server. And whatever command we will be firing, those will be redirected to this server. And those commands will be executed here. Got it? So that is also possible here. So it's a client server architecture. Okay. Client communicate with Docker daemon via socket or through RESTful API. So right now it's a world of API. So here they have various API endpoints. So we can use those API endpoints also. And using those API endpoints over the HTTP protocol, we can communicate with them. But we are going to see mostly the things associated with command line utilities. Docker is written in Go language. Go language is written by Google. So again, Go is again functional programming language. And nowadays, most of the Google work is being written into the Go language. They are trying to mold it for data science as well. But again, Python is pretty much evolved and lots of libraries are written into the Python. So it's very hard, at least when it comes to the data science, to replace Python immediately right now. But they try to do the same thing with the Go. So this Docker is written into the Go. Now, this diagram is very important. Okay, so this is my Docker host. So this entire thing is my Docker host. Okay, This is my client. So most of the cases, same Docker host, we can make it as a client, or we can make some other machine also as a dedicated client. And this is my registry. So again, let me give you this example. So what we saw Git, right? So let's talk about these three things. So Docker client, Docker host or Docker server, and this is my repository. Okay, Docker repository, Docker registry. Registry means, again, what happens here? I'll give you the internals here. This is Docker host. They mentioned Docker host, so deliberately I'll call it Docker host, but it is Docker server, and this is Docker client. Okay. So now when I talk about images, right? So what happens? This is my Docker registry. So ideally speaking, this Docker registry is nothing but Git repositories. Okay. So whenever we talk about Git repository, so Git repository, what will have? Git repository will have that Docker image and its supporting files also. So whatever Docker image and supporting files are there, those will be checked in into the Git repository. That is what my Docker repository in this case, Docker registry, right? In this way. So let's assume that this is Alpine image. So we will talk Alpine image, Ubuntu Xenial image, CentOS 7 image, vanilla image, nothing is installed, just CentOS and basic utilities. So what happens? This is my Docker registry where actually it is a Git repository. So in order to bring these images on my local machine, what I need to do, if I talk from Git point of view, I need to pull this image, right? Git pull. So similarly, there will be a command, Docker pull. And what this Docker pull will do, it will bring this image locally. So as per Docker setup, this image will be available locally at certain portal location as per the Docker setup. So when we install Docker, so they will have predefined location. When I pull this image, it will go into that location. And after having this image, then there will be a Docker command, Docker run command with that image name. And I'll create the running instance of that image. So that becomes my Alpine running Docker instance. So similarly, if I want to run Ubuntu Xenial, if suppose I want to run some other image, so I'll bring that on my local machine from Docker registry, and it will create the instances. So from one image, I can create multiple instances, multiple containers here. So in this way, these were the containers. Suppose from here, I create only one. From here again, I create three instances, three images, three containers from this one single image. So pretty much possible, right? Pretty much possible. So there will be one container here, and there will be three different containers here of this image, right? So in this way, these things are there. And then Docker client, actually what Docker client does, it fires this command. So Docker run this image. So it will spawn this container. Docker pull this image, it will fetch this. Docker kill this image, it will Docker kill this particular instance, it will kill this instance. It will go out of memory, right? So those things are done by the Docker client. Now, considering this architecture, right? This is the architecture at high level. So we have same set of commands. So command is how pull the data, then spawning the image. So again, there will be certain commands related with loading the images, removing the images, Docker RMI, it will remove the images, then running the container. So it's an operating system container means. So we can run it in a detached mode, means I'm not interactively running. Those operating systems are running in a detached mode, or attached mode means I'm running interactively, means I'm within this operating system and whatever commands I'm typing, those commands are being executed within this container. So that is what attach mode. So while running this image, I can directly attach and run that instance in attach mode, and I can type the commands, and instead of running it on local machine, those commands, so those commands will run into this container, this machine, this instant, right? So in this way, all these commands will be there. I can kill, docker kill, right? And now coming to the networking, so we have one single interface here, right? There are two things which are very important. We have an interface. Interface means network card, NIC card, right? And whenever I say open this for port number 80, so port number 80 is open on this. But what about these machines, this container? So what will I'll do? I'll say that open port number on this machine. Okay. And so here I open that port number 80. And I'll say attach this port number on port number 80 of local machine. So because of that, what will happen? This is called port redirecting. So first, my internet traffic will come on this port number 80. From port number 80, it will go to the port number 80 of this particular container. But suppose I don't want to make it to the port number 80. Means what? Suppose I open the traffic on this particular operating system, this container on port number 80. And here I want to attach this port number to 9000, right? So suppose I want to fire HTTP request. So I'll say HTTP, whatever name here, IP address 80. So it will go to this machine. But suppose from outside, from this machine, I want to connect to this. So I have to give 9000 here because my traffic will come here on 9000. And then from 9000, it will go to the 80 port number here. So I need to do this kind of mappings also as part of the Docker setting. Okay, because we have single interface. Here they have virtual interface again, virtual. Here we have virtual interface again for each running container. We have virtual interface. We can open all the ports here, but here we can open. Suppose we open 80 port number. So here also we can open 80. 80 can be associated with local or it can be associated with container also. Okay. So here we have a limitation. Here 80, 80, 80 running here. But when it comes to the actual server which running all this container, we have single 80. So 80 can be attached with one of the container only here, not with all the container. We can attach it with this, and some web server is running here. So that will attach, and that way external world will communicate with this port number, not the port number on this container. So they can be same or they can be different in this case. Got it? Then another thing is volume. When we run all these kind of things, volume means what? Volume means your hard disk, right? So now this main machine, main server, which is running the all these containers. So it has some hard disk here, right? Some hard disk here. Now, in order to create the hard disk space for this container, we create a volume. Volume is nothing but the mounted location here. So we call it volume. So this will be the hard disk, means some folder location, which will be mounted with this container. So that will be the volume. Similarly for this, and we can create a multiple volumes here. Huh? So we can attach this volume also, this volume. We have a different drives, right? So same fashion, we can mount all these things here, and that way that will be the hard disk for this virtual instance, virtual volume. So those volumes will be there. And that way, suppose this container, if we want to store any persistent data, persistent means permanent, should go to the hard disk. So we will create those volumes on actual hard disk, and those will be mounted with actual machine. And that way we call it volume. Volume means hard disk. Got it? Even CPU, take the example of CPU. We have one single CPU as far as this main machine is concerned. And suppose it has 8 vCores. 8 vCores. Again, this is all from admin point of view. And out of that, suppose we give 2 vCores to this virtual machines, 2 vCores to this virtual machine, 2 vCores to this virtual machine, and 2 vCores to this virtual machine. So 2, 2, 2, 2. And that way, those instances will be consuming, and they are actually running on this main CPU, but virtually we are assigning virtual CPUs. Got it? So in this way, these resources are distributed among all this container. And again, we can scale out. Suppose my processing increases. So within the container, I can make a provision where it will grow also. That happens with Kubernetes. That we will see it in Kubernetes. So all these things will come into the picture as far as Docker command is concerned. So again, what we can do, it is not just about pulling the images. So suppose you install some softwares here. You created your own Docker image with your custom application right now in your project. Suppose you are developing some application. You create your image here, and then you can push that image in Docker registry as well. Or you can create your own Git repository or registry, and you can put this is public registry. Docker registry is like a GitHub, right? So this is my Docker registry where I'm pushing my custom image with custom softwares in it. So this is what this git build command. We can build images, we can pull images from registry, bring it on our local machine. We can run the Docker run, right? So this is what, in short, Docker architecture. So if you understood this and if you are listening me carefully, then just type DA in the chat window, DA for Docker architecture. And if you have any question related with this architecture, please feel free to put Q in the chat window and feel free to unmute yourself. Okay, it is 10:06 in my clock. So again, we have plenty of time. But if you fail to understand any concept, just feel free to ask me those questions here right now. Okay, this is again very high level architecture. Again, internally, there will be more complexities. But this is what Docker in a nutshell, in a very easy to understandable concepts. Now, this is what VM and container, whatever I was talking about. Anybody, any question? Feel free to unmute yourself and ask those questions. I want to see whether I started recording. Yes, I started. So this is what VM. So again, you can see this is my server, and below server we have a hardware, right? Whatever memory, CPU, and hard disk we talk about. Then we have a operating system on actual server. And then this is the virtualization layer, which is hypervisor in case of VM, right? In case of Dockerization, containerization, we have a Docker layer. So it's a Docker engine, which we are installing here. All the necessary libraries to do that virtualization of this container and images. That is what this Dockerization layer. This is hypervisor virtualization layer. And when we spawn the VM, we spawn it along with the OS. Actual OS will be there. So whatever OS with that VM is created and whatever custom application which are installed on top of that OS, those will be there. But again, there will be additional overhead of this OS, and that's where it will end up consuming my underlying server resources. So when I talk about server resources, mainly it is memory and CPU. And Docker revolutionized the same concept. So instead of having that cached OS or actual OS, we have a tools and libraries of respective operating systems. And these tools and library interact with the actual OS here, which is underlying servers OS. And on top of that, we have our own custom applications, right? Whatever web server and the things. So those will be installed. So this is what VM architecture. This is what container architecture. Just type VC if you understood the difference between VM and container. Just type VC in the chat window. V for VM, C for container. Okay. So Smita understood it, Project understood it, Pushkar is there, and Saksham also understood it, right? Now moving on to the next part. What are the benefits of container? Yes, yes, Pushkar.
Whenever we are creating a containers over here, right? And you mentioned that we can open the ports and we can close the ports on fly. But can we assign the resources on fly?
Oh, that we do. Yes, we can assign resources also. How much memory? Suppose I created.
Yes.
I created this container with 2 GB of memory, right? But on the fly, I want to change it to the 4 GB. Suppose I allocated 2 vCores, but I want to change it to the 3. So that is possible. And that we do in a better way in Kubernetes. So Kubernetes is that orchestration tool which takes care of all these things, right? So we can change those resources as well. Okay.
Okay, okay, sure. So can I say Kubernetes and Docker both are containers and they work parallelly or they work hand in hand together?
No, 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 no. See, uh, I mean, when we will talk about Kubernetes, I'll give you exact difference between what is Docker and Kubernetes. So whatever we are learning, that is Docker. And in order to manage this Docker, which Docker should spawn at what time, and if suppose that Docker fails, then immediately I need to start some other Docker, right? Otherwise, in production, my service will go away. Or suppose there is too much workload on one Docker and immediately I want to distribute that load on by creating some other Docker image and do that load balancing. So all these kind of things dynamically I can do using Kubernetes. So Kubernetes is that orchestration tool.
Okay.
Got
Okay.
it? It is a resource management tool. Whatever you ask the question, exactly that Kubernetes does. So Kubernetes is that resource management tool. So which Docker will get how much memory, how much scale up it can do, and all those things that we do using Kubernetes. Kubernetes is resource management tool. And Docker is actual image, actual instance which is running, and how to manage that running instance, that is done by the Kubernetes. If I want to tell you in short, so what you can think of, all the people in your project, developers. So there will be a C# developer, Java developer, Oracle developer. There will be a tester. So all these people are nothing but your container. So this is Java container. This is Oracle container. This is testing container, right? And as a PM, it is a Kubernetes. So Kubernetes will go and say, take this code and run this Java program. Take this code and test this program. Take this Oracle, or we need a database and please work on this database side. So who should do what and when and how to communicate with each other, that will be decided by the PM. So PM who are orchestrate their behavior, ask them and give the direction and allocate the resources. So that is nothing but the Kubernetes in this case. Got it?
Okay. Thank you.
So what is the benefit of container here? Agile application creation and deployment. Agile means at the runtime we get all these things. We don't need to fast way, increases the ease and efficiency of container. And again, we saw right these days, it's all about CI/CD and fast development. So same application I need to deploy it in on mobile. In mobile again we have a iOS, we have a Android. Again, suppose same application I want to test it on CentOS, Ubuntu, and some other Windows software, Windows operating system. So that ease of and flexibility mainly we have when it comes to the container. So we have those respective container. We can deploy our application into those container and we can test them very quickly, very fast, very fast. So right now the role of developer is changing into more on the infrastructure side also because of this container. So you are no more just developer or tester. You are infrastructure engineers also by adapting this Kubernetes and container kind of applications, right? So that's where even if you are tester, developer, or project manager, it's necessary to at least understand the crux of this Docker and Kubernetes. Very powerful tools, very powerful technology. Okay, provides for reliable and frequent container image build, deploy with quick and easy rollback. So you can easily, suppose you release something in the production and you feel it is wrong. So you can roll back those changes very easily. Means what? Suppose tomorrow you release something. You had a version 2.0, and with version 2.0 you created some image here, v2.0, means your own custom application on some operating system, and you created that image and you are running in production, but suppose it has some major bug. So it's very easy. We'll offload this, you must be having your container, your image already with v.0, sorry, v.0.1, right? Oh, sorry, v1.0. So what you will do, you will remove this container, you will spawn this old container, your application is ready with old version. Previously, what was the case? You need to go manually, build that code, deploy that code, change all those things. So it was big headache actually to roll back all these things. Sometimes it was taking weeks also. Sometimes it was taking more error prone things also. Because when I say v.0 means it is not just one application. There could be 10 other applications which I'm changing and I need to roll back everywhere. But right now I have respective compatible versions of dependent application. I can take those images, spawn those container, and that's it. Very easy rollback. So that's where it is very important for CI/CD. Dev and operation separations of concern. So most of the cases we have a support team, operation team, and development team. But right now that gap is being bridged right now. Create application container image at build and release time rather than deploy time, and thereby decoupling the application from infrastructure. So it's like a more coupling between operation and dev. So whatever you develop directly, same thing you are deploying as a production release, right? Observability, not only surfaces OS level information and metric, but also application health and other signals. So it's very easy. So previously what was happening when we have a segregation between operating system and application. Suppose I want to migrate from REHL 7 to REHL 8. It was a big task. So I'm updating my operating system. So I need to update operating system. And again, I need to check. Suppose I have a Hadoop 2.7. So I need to check the Hadoop 2.7 compatibility with REHL 8 to which I am migrating and whether it is working or not. So very dangerous when it comes to the first I need to test all this thing in non-production environment, then in production, again in production, how it will react, we don't know. So big headache. I went through those, but right now in container things, it's very easy. You can check those compatibilities and you can quickly fix those issues, or even at least surface level, you can take good decision whether this piece of software really compatible with this operating system or not, and then we should migrate to that operating system, or that application should sit on this particular that particular application should sit on this particular OS or not. So those are the advantages. Environmental consistency across development, testing, production. So same image is being used everywhere, right? So that environmental consistency will be there. Cloud and OS distribution portability. So same cluster you can create on the cloud environment with same kind of operating system. We can create a Kubernetes cluster on Google, AWS, or even Azure, and it has the consistent behavior, right? Same type of things we can set up, and it's very easy for testing. Application centric management raises the level of abstraction from running OS on virtual hardware to running an application on OS using logical resources, right? So the focus is shifted from operating system to applications here, right? Loosely coupled and distributed elastic liberated microservices. So most of the cases, this containerization technique is used for microservices. Okay, so right now we see lots of microservices driven kind of applications, right? Now world is more shifting toward the microservices. So if I develop one microservice and if I want to deploy, so there will be dedicated endpoints for each microservices, and mostly for microservices kind of environment, we use this Docker, Kubernetes kind of application. They are more popular for those kind of use cases. Resource isolation, we saw, right? Predictable application performance. We have those resources isolation, better utilization of my servers. So if suppose any application is not running, so previously suppose I have a server and only one application is running on that server, which is consuming only 2 GB. So rest of the 14 GB, suppose that server is of 16 GB. So 14 GB was being wasted. But right now, as I deploy multiple containers, so it's a better utilization of my servers, right? So better utilization of resources. Now this is Docker benefit. How they have shown here, you can see here at the bottom, when we using Docker, we have 3 machines. Here we have a 4 machine, little bit blur application, blur image. But what they are saying in both cases, so let's take this example. What I can see here, we have 4 machines here, right? And we are running 1, 2, 3, 4, 5, 6, 7, 8. 8 virtual machines here. You can see Gate OS and some applications. So 8 virtual machines running. This is my hypervisor layer. So this is my cluster of 4 machines, and there I'm running 4 virtual machines here. Now here, this is my one single server, consists of multiple hardwares, and I'm running it on the top of VM. Means you can see here, this is hypervisor. Hypervisor has its guest OS, and we have a, on top of that virtual machine, on that guest OS, we have a Docker engine. So this is my virtual machine on top of these hardwares. And there I'm running multiple containers here. 1, 2, 3, 4, 5, 6, 7, 8. 8 containers I'm running. So here we need more hardwares for same setup. Here we can run it on less hardwares, and still these are more efficient when it comes to the performance. These containers which are deployed on top of virtual machines, it is not bare metal. It is, if you see here, we have a hypervisor, means this is my VM, single VM. On top of that VM, we are running all this container. So from 8 VMs to 1 workload each. Okay, so one VM will have certain application workload. So one VM will be running one application to one larger VM with 8 container, one single VM which running 8 container. Do the same work with 25% fewer compute resources. So these are more efficient, saves 25% of resources, and these are some additional savings. So what they claim, 30 to 35 less storage, 7% less RAM required, fewer OS and hypervision to manage. So even this virtual setup, virtual machine setup, and on top of that virtual machine, suppose I'm running this multiple container, they are more performant than actual VM setup of this type. So that is there. Then again, this diagram is there. What this diagram says. So now this is the setup same as that of this. Whatever we are doing, same setup is here. But now this setup is done on the actual bare metal machines. This was the setup on virtual machine, previous slide. And now this slide, which is on the actual bare metal, and we have a native operating system. If you go and see here, we have a hypervisor and the guest OS of that VM machine, which was here. Here it is a native operating system which is running on that bare metal machine. So the way I'm running my machine right now, that kind of setup here. And then we have a Docker engine and multiple containers are running. So from 8 VM, we have a one workload each. So each VM we have one workload. So 8 container running on bare metal. So we have 8 containers running. And see, when we go for this kind of setup compared to this VM setup, we do the same work with 7% fewer compute resources. So in previous case, it was 25% saving. Here we have more saving when we deploy this Docker setup on actual bare metal machines. Okay, they are more performant and less, 30% less storage, 7% less operating system, and there are other benefits. So compared to this VM setup, this bare metal setup is more powerful with operating system on top of that, and then Docker engine. Okay. And please go to this Docker Hub. I'm putting in the chat window this link. Okay. So Docker Hub is like our GitHub, but Docker Hub stores the Git images. So please go to this link. Already I have created account there. So you can also create account on Docker Hub. So let me open my Docker Hub account here right now.